Hey y'all, it's Miss G here, and we are going to talk about 2.4, our last section here in our Chapter 2 notes. So please make sure that you've got your blank note sheet with you, and we're going to be talking about solving two-step inequalities today. Make sure you put your name on your paper. We've already talked about this in class. I'm recording this video after our initial discussion about 2.4, so hopefully this really solidifies your understanding of things and allows you to fill in your notes. So let's dive in. To solve two-step inequalities, use inverse operations to isolate the variable. So just like we talked about in class, all of these steps are things that we were doing when we were solving equations. So the opposite of addition is subtraction. The opposite of multiplication is division, all right? And if you want to write those out, you can, okay? So addition and then subtraction go together, and then we have multiplication, and division, okay? Those are inverse operations. All right, so same thing that we've been doing before. This is how we undo everything to really isolate the variable and solve our inequalities, okay? So if we were to have a fractional coefficient, let's say we had something like 5, 6x is greater than, let's see, 10, okay? So if we wanted to get rid of this fractional coefficient right here, what would we do? We would multiply by the reciprocal, okay? By the reciprocal. So that would mean the reciprocal of 5, 6 is 6 over 5. So we would multiply by the reciprocal. When we do that on this side of the inequality, we have to do it on the other because that allows us to cancel those out. All right, and so we would go ahead and say 60 divided by 5, because 10 times 6 is 60, 1 times 5 is 5, 60 divided by 5 is 12. All right, so this is how we would multiply by the reciprocal as an example, okay? So the entire goal of solving, okay, with our inequalities and of course with our equations is that we want to isolate the variable, which means get the variable by itself. Okay, that's what isolate means. So get the variable by itself. All right, so isolate, that's the definition right there. Okay, so let's go on ahead and work into some of these practice questions and see how it goes. Okay, so we have the inequality 5x minus 4 is greater than or equal to 11. Our instructions tell us to solve and then graph the solution on a number line, just like we've been doing in class. So we're going to work through the steps that were the same steps as equations, okay, but just with one extra little step. So the first step that we would do is we would say, are there any parentheses? No, there are no parentheses. Second step, let's box and bubble so that we can identify the terms in the inequality. So these are all the same ones that we were doing in the previous chapter, all right? So then we would say, is there anything we can combine together on one side of the inequality? Nope, we can't combine a bubble and a box. Nothing to combine on the right side. So the next step would be to use addition or subtraction to isolate this variable term. So we want to get 5x all by itself. In order to do that, we're going to do the opposite of minus 4, and we are going to add 4. When we do something to one side, we got to do it to the other. Then we would say 5x is greater than or equal to 15. Okay, so remember, every time that we write something, we're either writing the change that we're making or we're writing a full new inequality with it updates per the change we made. Okay, so we keep it very organized. Then the last step would be to use division or multiplication to isolate the variable. Right now this 5 is being multiplied by x, so to do the opposite would be to divide. So we're going to divide by 5 and have x is greater than or equal to 3. So this is the solving portion of it. Okay, remember you have to have the variable and a full inequality written out to solve. And then for our graphing, we're going to draw our number line. We're going to put this number right here in the middle, and then we add 1 to it. We take 1 away, and we say it's going to be a closed circle because I have the or equal to line. And then I'm going to take this to the right because it says x is greater than or equal to 3. And the way that we can check our answer is we take this number and we plug it in and we say, is that true? 4 is greater than or equal to 3. check, I know that I graphed my solution correctly. Okay, so when we talk about having two-step inequalities, this took us one step, it took us 2 steps to be able to solve. That's what we mean when we talk about having a two-step equation. Okay, so let's try this second example over here. So are there any parentheses that we need to undo? Nope, no parentheses. Okay, so now it's time to bubble and box. So that is a constant, just a number. This has a variable inside, and this is just a number. All right, so it doesn't matter if the variable's on the right or the left, the bubble and box is still the same. Okay, next, is there anything we can combine on this side of the inequality? Nope. Anything to combine over here? Nope. All right, now it's time to use addition or subtraction to be able to isolate this variable term. Okay, so we want to get this all by itself, which means we have to get rid of this plus 4. So we're going to minus 4 from both sides. We update our inequality and we would say that is 9 is greater than b divided by -3. Okay, now it's time for me to use multiplication or division to be able to undo what's happening to the variable b. b is being divided by -3, so that means I'm going to choose to multiply by -3. -3 times 9 is -27 because a negative times a positive is a negative. Okay, that cancels out those 3's and I have b over here. Okay, and then I have to ask myself, because I see that I had a negative number that I multiplied by. What do we do when we multiply or divide by a negative number to solve? We always flip the sign, okay? So we would flip it from a greater than to a less than. If you're someone that's much more comfortable with the variable being on the left, this could also be written as b is greater than -27. So you could write it either way. All right, and then we would need to go to graphing our solution, okay? And so we would say, here's -27, and then when I add 1 to -27, it turns to -26. When I take away, it gets smaller to -28. It's going to be an open circle because there is no or equal to, okay? And then I have to figure out which way am I going. It says b is greater than -27. So that means it's going to be going to the right, okay? So on this example, if you noticed right here in this variable term, there was a negative, right? So that's telling me that I'm going to flip, right? When I look over here, this variable term, it had a positive coefficient, which meant we were gonna no flip. Okay, so remember that can help you identify when you need to flip or not flip in case sometimes you're forgetful when you're in the middle of solving. Okay, so let's see. Let's move on to this last one, or this graphing one. So it says, which graph represents the solution of -7 times the quantity x plus 3 is less than or equal to 28, okay? So can I choose a graph right now? No, I cannot, okay? Because we cannot graph it unless we have already solved. So we need to bring this inequality over here, and we need to actually solve it so that then we can identify the graph, okay? And for those of you that tend to just jump to the answer whenever there's multiple choice, remember, we always work the problem ourselves and see what our answer is, and then we go back and see if the answer is present in our choices, okay? So first question, are there parentheses? Yes, there are, which means we need to distribute. So we're gonna multiply this -7 times x, and then we're gonna multiply the -7 times the 3, which gives me -21, and then I just continue to write the rest of my inequality. So here's my updated inequality now that I have distributed, and I unlocked my parentheses. Cool. So next step, box and bubble. So I'm gonna put a circle around that term because it has the variable. -21 is a constant, 28 is a constant, and now I'm gonna look to see if there's anything to combine on either side. I can't combine, nothing to combine over here. So now it's time to start solving. So I want to get this -7x all by itself. So we're going to add 21, and then we're going to add 21 to the other side to keep it fair and balanced. That leaves us with negative 7x is less than or equal to 49. Now we're to that last step where we have to multiply or divide to isolate the variable completely by itself. So I'm going to divide by negative 7. I'm going to divide by negative 7. This dividing by a negative is already hinting to me at what I need to do with the sign. So this cancels out and I have x. Instead of it being less than or equal to, this negative 7 right here that I divided by means I have to flip my inequality symbol. And then 49 divided by negative 7 is a negative 7. So now that I have this, now let me go see what I have going on over here, okay? So let's see. This one has a negative 7, okay? This one has a negative 7. This one is at 7 and 7, so I know it's not those because my solution is with a negative 7, not a positive 7 on the number line. So process of elimination. Now I have to figure out which way I'm going. So if I were to solve this and I were to graph it myself, and I put the negative 7 right here, I would say I have a closed circle, and I would say x is greater than or equal to, which means it's going to go to the right because it's getting bigger. So I'm going to choose B because B matches the way that I solved the problem. Okay? All right, guys. So we've talked about it in class. Here's just another set of examples. We're going to keep practicing before your test, okay? So if you have questions, make sure you're writing them down or bringing them to class. Let's do the word problem because, of course, we always want to be able to solve real-world situations using our math. As you guys have asked me in class, what in the world am I going to use this math for? Okay, so it says, a football team orders the sweatshirts shown. Okay, here's the sweatshirt, the Grizzlies football, okay? And it says a price tag here of $40, okay? So this is the sweatshirt they're talking about. The price per sweatshirt is discounted 5 cents for each sweatshirt that is ordered. How many sweatshirts should the team order for the price per sweatshirt to be no greater than $32.50? Okay, so I see some things in here that I want to make sure I circle and underline. So I see that the sweatshirt is discounted 5 cents, discounted meaning taken off, right? Less, right? Take away. The price per sweatshirt is discounted 5 cents. So that tells me it goes down 0.05 cents per shirt that gets purchased, right? How many sweatshirts should the team order for the price per sweatshirt to be no greater than $32.50? Okay, so I already kind of know the $32.50 is important. So I have, let's see, $32.50 is where we want the price to be, right? We don't want it to be any more than that. And the starting price was $40, okay? And then the discounted price was 5 cents per shirt, right? So 40 was the original, and this is our goal price. And we want it to really be less than or equal to $32.50, right? We want it to be no greater than, okay? Less than or equal to. That's our goal right here. So how are we going to figure this out? Well, first we need to look at and say, well, how many sweatshirts do I have to purchase to make the price go from a 40 down to a 32.50? So first I'm going to say $40 minus 32.50 is $7.50. Okay, so we're looking to see how many times do I need to go down in price by a nickel to get to $7.50. So then I'm going to say $7.50 divided by the cost of 5 cents per shirt. So how many shirts make up $7.50? Okay, so that would be 150 shirts because 750 divided by 0.05 is, not 1.5, 150. The other way you could think about it is 150 times what gives me $7.50 off of my price, okay? And so then if you were to take 750 divided by 150, if you were to solve it this way and you say divided by 150, that got us right back to the 0.05, right? Okay. So you can kind of think of which way you want, right? So we're already here. I need this number of shirts or more to be purchased because 150 gets me down to this price. But the more that I purchase, the less this price will go. And that's our goal, right? So when I write how many sweatshirts, not the price, how many sweatshirts could the team order, I could say the sweatshirts need to be more than or equal to 150. Because if we purchased exactly 150, then we would have the price per sweatshirt of $32.50. If I were to purchase 151 sweatshirts, well, if I multiplied that times 0.05, that means that I'm going to have $7.55 off, which means that my price per sweatshirt is $32.45. So that's meeting my goal of having a price no greater than $32.50. Okay? So maybe some of your logic you were able to get the same way, but you kind of talked about it in a different way. But remember, with word problems, we're not going to just have like a straight line answer. Sometimes we really have to sit and think about it to put the pieces together. Okay? So how many sweatshirts they would need to order? At least 150 sweatshirts. Okay? All right, guys, these are your notes. Make sure that you fill them out. This is your last section for the chapter. Make sure you have 2.1 through 2.4 so that you can turn them in when we have our test next week. I will see you in class.